So we're going to finish up our derivation of the energy-momentum relation. In the first video, we showed how gamma can be represented as a function of momentum. In the second video, we showed that our postulate regarding the total energy of a system satisfies a low speed condition where we have this kinetic energy term. We have a kinetic energy term as well as this atomic energy. Einstein's famous E equals mc squared. So we showed that condition is satisfied, and now we're just going to carry on the math and see what is resulted. So going back to here, I'm going to square both sides. So you get E squared equals gamma squared times m naught c squared all squared. Gamma squared is equal to 1 plus p over m naught c all squared, and then multiply this by m naught c squared all squared. And then we get E squared epsilon squared equals m naught c squared squared plus, and I'm going to write this out just so I don't mess this up, there's a lot of squares going on here. We get p squared over m naught squared c squared times m naught squared c to the 4. Okay, so we get E squared, actually let's cancel some stuff while we're down here. The c squareds on the bottom cancel, so we're left with a c squared on top. The m naught squareds cancel. We get the relativistic energy momentum relation, m naught c squared all squared plus p c squared. Okay, we're going to spend the rest of the video dissecting this a little bit and talking about this very, very famous equation. There's a couple things to note. First of all, it does look like a sort of Euclidean norm. It kind of looks like a Euclidean norm, a squared plus b squared. And what Euclidean norms often represent, if you picture a triangle, is that as the dimensions of the triangle shift and stretch and shape and change, there's a trade-off between a and b compared to the magnitude z. Okay, so the notion here is that there's some trade-off between rest mass and momentum, because the c's are obviously constant, the speed of light is constant, but there's a trade-off between rest mass and momentum. So there is a fascinating thing that you can do with this equation where you take this to the nth degree. Okay, you take our little triangle here and you stretch it out all the way till a basically goes to 0, and then the whole thing collapses to E squared equals PC squared. PC squared. And this is true for a photon. This is what Einstein said. This is a photon. Okay? And a photon has no rest mass. There's a very sort of beautiful logic here. Photons travel at the speed of light. The equations of special relativity show us about time dilation and length contraction as massive objects approach the speed of light. And now we finally come to the logical assertion that photons have no rest mass and that their energy is purely momentum. So photons have no momentum. Sorry, photons have no rest mass, but they have momentum. This is sort of an incredible discovery in theoretical physics. Let's follow a line of reasoning here. We're going to get to the de Broglie relation from this derivation. So we're saying that photons have no rest mass, and this has come from our energy momentum relation. The algebra here is dead simple. Remember, recall, and I'll post a link to the video, recall, and we showed that E equals h nu for a photon. This is the energy function that resolves the ultraviolet catastrophe. This is the energy output of a photon radiating out from a black body. We also just stated that epsilon equals PC. So obviously we can equate these two things. So we get PC equals h nu. So P equals h nu over C. Combining, this is the particle side. So this is the particle side. Well, what about EM waves? We know that light propagates as an electromagnetic wave. We cannot dispute that fact either. So what relation do we have there? We have the speed is equal to the wavelength times nu. Okay, so we can show that nu over c is equal to 1 over the wavelength. Combine these two bits of logic and you get the classic relation that momentum is equal to h over lambda. This is an extraordinarily bizarre result. We're saying the momentum of a photon, which has no rest mass, is purely due to its wavelength or frequency, and also to its moment. It has momentum due to its wavelength or frequency. So I think this is where the math stops in this video, and I'm going to probably do another one soon on the Schrodinger equation, because these concepts that I've discussed in my videos regarding probabilities, looking at statistical mechanics and how important the viewpoint of statistical mechanics is in terms of the development of quantum mechanics. There's a lot you can develop with this relation. And what it all goes back to, our postulate about the total energy of the system, this postulate. So all of this can be derived from that postulate. Anyways, guys, thanks for watching. Please like and subscribe, and comment below if you have any thoughts on what this video is about, and any criticisms, anything at all would certainly be welcome. Till next time.